You begin with something small. A cup of tea rests between your hands. Steam rises in delicate spirals, visible only for a moment before dissolving into the air. You do nothing. You simply sit. And slowly, almost invisibly, the tea cools. It never grows warmer on its own. The warmth slips away into the room, spreading into the air, into the walls, into the quiet space around you. The heat does not vanish. It moves. It disperses. It becomes shared. You have witnessed this countless times, and yet tonight you pause long enough to feel it. There is a direction to this change. A preference. Warm things cool. Ordered things loosen. Structures soften. The universe leans, gently but persistently, toward a wider spreading. This leaning has a name, entropy. The word sounds technical, almost severe. But what it describes is tender and ordinary. Entropy is not destruction. It is not chaos crashing in. It is the simple tendency for energy to spread out, for differences to even out, for concentrated things to diffuse into the larger whole. Imagine a drop of ink falling into clear water. At first, the ink holds its shape dark and defined. But then it begins to feather outward. Tiny currents carry its color into the surrounding liquid. Swirls form, delicate and intricate. Eventually, the water becomes uniformly tinted. The ink does not disappear. It becomes everywhere at once. This is entropy at work. It is the quiet drift from concentrated to dispersed, from particular to shared. And it happens not because the universe is careless, but because there are simply more ways for things to be spread out than to be neatly arranged. You glance around your room. Dust gathers on the shelf. Paper shifts slightly out of alignment. Fabrics wrinkle. These changes feel like small rebellions against order. But they are not rebellions. They are the natural outcome of countless tiny motions, molecules in the air bumping gently against surfaces, gravity pulling softly downward, atoms vibrating with restless energy. Every atom is in motion. Even in stillness, there is movement. At the microscopic scale, nothing is ever truly at rest. Particles jostle, collide, exchange energy. The dance never stops. And in this ceaseless motion, energy spreads. Entropy is the measure of how spread out that energy becomes. When energy is concentrated, like heat in your tea, entropy is lower. When energy is evenly distributed, like warmth shared with the entire room, entropy is higher. The universe does not command this change. It simply follows probability. There are more possible arrangements in which energy is spread thin than arrangements in which it is tightly gathered. Think of a deck of cards. When freshly opened, it arrives in perfect order, suits aligned, numbers ascending. That arrangement is precise, intentional. But shuffle it once, twice, 10 times, and the order dissolves into randomness. You could shuffle forever and almost never return to that original sequence. Not because it is forbidden, but because it is statistically rare. Order is possible. Disorder is probable. This is the quiet secret of entropy. It is not about messiness. It is about likelihood. The universe moves from less likely states to more likely ones. A hot cup cooling in a cool room is simply energy moving toward a more common arrangement. It is easier, in a statistical sense, for warmth to be shared than for it to remain isolated. You might begin to feel a subtle comfort in this. The fading of heat, the dimming of light, the soft wearing down of edges, these are not signs of failure. They are expressions of a vast and gentle rule that touches everything. Even the sunset obeys it. As the sun sinks below the horizon, its light scatters through the atmosphere. Blue wavelengths disperse widely during the day, painting the sky overhead. At evening, the light must travel farther through air, and reds and oranges linger. The glow spreads, diffuses, softens. The day's concentrated brightness becomes a wide, fading wash of color. Nothing abrupt. Nothing violent. Just a gradual drift. You breathe in, and the air enters your lungs. Oxygen molecules move from higher concentration outside your cells to lower concentration within them. Diffusion again. Gradients smoothing out. Even your breath participates in entropy's quiet flow. And yet, as you sit here, you might wonder, if everything spreads out, if all differences tend to even, why does anything structured exist at all? Why are there stars, trees, minds, rooms carefully arranged? The answer is subtle. Entropy always increases in an isolated system, a system with no outside influence. But many systems are not isolated. Your room exchanges energy with the outside world. The Earth receives concentrated energy from the sun. Life feeds on these flows. Local pockets of order can arise, but only because somewhere else, entropy increases even more. When you clean your desk, you create order in one small corner of the world. But your body burns calories, releases heat, increases entropy in the surrounding air. Order here, greater disorder there. The total still rises. The second law of thermodynamics states this plainly: in a closed system, entropy never decreases. It can remain constant in rare ideal conditions, but it most often grows. This law is not enforced by force. It is guided by mathematics, by counting possibilities. There are more ways for atoms to be mixed than separated, more ways for heat to be dispersed than contained. And so the universe drifts. You begin to see entropy not as decay, but as unfolding. A flower wilts, yes, but in doing so, its molecules return to soil and air, to future growth. A log burns, releasing stored sunlight as warmth and light, spreading energy outward. Nothing is lost. Everything transforms and redistributes. Even stars will one day exhaust their concentrated fuel, radiating their energy into the vastness of space. But that is far ahead. For now, you sit with the simple truth: your tea cools. The room warms slightly. The difference fades. Entropy is not a villain. It is a current. A direction woven into reality itself. And as you notice this gentle drift in warmth, in light, in the quiet settling of things, you may begin to sense something deeper beneath it. Because if entropy always increases, if energy always spreads, then time itself seems to have a direction. The tea cools forward, never backward. The ink spreads outward, never gathers again. You wake each morning facing forward. Not physically, you could turn around if you wished, but temporally. Yesterday feels fixed, settled, complete. Tomorrow feels open, unwritten. There is a direction to experience, as steady as a river's current. You move from memory into anticipation, never the reverse. This direction feels so natural that you rarely question it. And yet, in the quiet of evening, when the air cools and your thoughts slow, you might wonder, why does time move only one way? A glass slips from your hand and shatters on the floor. The fragments scatter in a jagged pattern. You can imagine the moment before the fall, the glass whole, intact. But you cannot imagine, with the same ease, the shards lifting themselves, flying upward, reassembling into a perfect cylinder, and landing gently in your palm. Nothing in the basic laws of motion forbids such a reversal. The equations that describe how particles move work just as well backward as forward. If you filmed 2 billiard balls colliding and played the footage in reverse, the motion would still obey physics. And yet, in your lived world, some things happen only one way. Ice melts in warm air. It does not spontaneously gather heat from the room and refreeze into a flawless cube. Perfume diffuses through space. It does not drift back into the bottle. Your tea cools. It does not grow hotter by borrowing warmth from its surroundings. This one-way tendency is called the arrow of time. Entropy is its compass. Earlier, you sensed entropy as a quiet spreading, energy dispersing, differences softening. Now you begin to see that this spreading gives time its direction. The future is the direction in which entropy increases. Imagine a simple box divided into 2 compartments by a thin barrier. On one side, a gas is trapped. On the other, empty space. When the barrier is removed, the gas molecules rush outward, filling the entire box. They spread until they are evenly distributed. Could they, by chance, all drift back into the original half? In theory, yes. But the probability is so vanishingly small that it might never occur in the lifetime of the universe. There are vastly more ways for molecules to be evenly spread than clustered on one side. So once the gas expands, it remains expanded. You look at the box at 2 different moments. One moment shows molecules neatly confined. The other shows them scattered evenly. Without knowing anything else, you can tell which moment came first. The clustered arrangement is less probable, lower entropy. The evenly spread arrangement is more probable, higher entropy. Entropy becomes a clock without numbers. It allows you to distinguish past from future by measuring how spread out energy has become. You do not remember the future because the future has not yet unfolded into higher entropy. Memory itself depends on physical processes, tiny chemical changes in neurons, electrical signals flowing across synapses. These processes increase entropy in your brain and body. To form a memory is to create a physical trace, and creating that trace generates heat, disperses energy. Your memories are records of entropy increasing. The past feels fixed because it corresponds to states of lower entropy that have already transitioned into higher ones. The future feels uncertain because many possible arrangements remain open, not yet realized. Close your eyes for a moment and imagine rewinding your day. The crumbs on your plate leap back into a slice of bread. Steam condenses into a kettle. Words you have spoken return to your mouth. It feels unnatural, almost unsettling. This discomfort is not philosophical. It is statistical. Your mind expects entropy to rise. The arrow of time is not embedded in the fundamental equations of motion. It emerges from probability. It arises because the universe began in a state of remarkably low entropy, and ever since, it has been unfolding toward more probable arrangements. If the universe had started in maximum entropy, perfectly uniform, completely spread out, there would be no direction. Nothing would change. Without differences, without gradients, without concentrated pockets of energy, there would be no processes to mark time. Time, as you experience it, depends on imbalance. Think of a wound spring slowly unwinding. The tension stored in the coil creates motion. As it unwinds, energy disperses into the surrounding air as heat and sound. Once fully relaxed, it cannot spontaneously wind itself tighter again. You are like that spring, too. You metabolize food, releasing stored chemical energy. Your body maintains order internally, but only by increasing entropy in your environment, breathing out carbon dioxide, radiating heat into the room. You live because there is a difference between the energy concentrated in your food and the lower energy state of your surroundings. Life rides the arrow of time. And so does every star. In the heart of the sun, nuclear fusion concentrates immense energy into radiant light. That light streams outward, spreading through space. Eventually, it disperses into the vast darkness, diluted across unimaginable distances. The sun cannot gather that same scattered light back into its core. Forward. Always forward. You begin to sense something profound. Time is not an external ticking mechanism imposed upon reality. It may be the name you give to entropy's unfolding. The reason yesterday feels different from tomorrow is that yesterday corresponds to a universe slightly more ordered than today. The arrow of time is not separate from thermodynamics. It is born from it. And yet, this raises a deeper question. If entropy must increase, if the arrow of time is set by probability, then why did the universe begin in such a low entropy state at all? Why was there an arrow to begin with? That mystery lingers like a distant horizon. For now, you simply rest in the recognition that the cooling of tea, the melting of ice, the fading of sunsets, and the forming of memories all share a single direction. A quiet one-way flow. You feel it in your breathing, in the steady rhythm of your heart, in the subtle sense that this moment will never repeat in exactly the same way. Time moves forward because entropy grows. And as you drift toward sleep, you might begin to wonder whether within this apparent march toward disorder, there are hidden patterns still waiting to be seen, subtle structures emerging even as everything spreads outward. You have been told that entropy means disorder. But tonight, you look more carefully. You imagine a jar of sand poured onto the ground. At first, the grains tumble in apparent confusion, scattering into irregular shapes. Yet as they settle, something curious happens. A slope forms. The pile arranges itself at a precise angle, neither too steep nor too shallow. Physicists call this the angle of repose. It emerges naturally, without instruction. Even in falling, there is pattern. You watch cream swirl into coffee. At first, the white ribbons twist unpredictably through the dark liquid. They curl and fold, forming delicate filaments. It looks chaotic. And yet, if you could zoom in closely enough, you would see that every swirl follows the laws of fluid dynamics. Each motion obeys equations that describe how liquids flow. Disorder, you begin to realize, does not mean lawlessness. Entropy increases, yes. Energy spreads, yes. But spreading does not erase structure. It often creates new kinds of structure, temporary, shifting, beautiful. Think of clouds forming in the sky. Warm air rises, cools, condenses into droplets. The droplets cluster, sculpted by currents of wind. Billows and spirals appear. From a distance, a cloud looks soft and shapeless. Up close, it is a precise dance of temperature gradients and pressure differences. The air is not disorganized. It is responsive. Entropy describes the number of possible microscopic arrangements consistent with what you see. When a gas fills a room evenly, it has high entropy because its molecules can be arranged in countless ways while still appearing uniform. But that uniform appearance is itself a kind of large-scale order. The paradox begins to soften. High entropy does not always look messy. Sometimes it looks smooth. A calm lake at dusk has high entropy compared to a sharply defined ice sculpture. The water molecules are free to move in many configurations. The ice is rigid, constrained, limited in its possibilities. Freedom at the microscopic level can create simplicity at the macroscopic level. You walk along a beach and watch waves roll toward the shore. Each wave seems unpredictable, yet the rhythm continues. Crest follows trough. Patterns repeat without being identical. The ocean's surface is a tapestry woven from wind energy, gravity, and the rotation of the earth. Turbulence, the irregular motion of fluids, was once thought to be pure chaos. But within turbulence, scientists find repeating vortices, cascading energy transfers, fractal-like structures that echo across scales. Disorder contains echoes of order within it. Even your own heartbeat fluctuates slightly from one beat to the next. Perfect regularity would signal danger. Healthy systems show variation, small, dynamic adjustments. Life thrives not in rigid symmetry, but in flexible balance. Entropy allows this flexibility. Consider a snowflake forming high in the atmosphere. Water vapor molecules collide and attach to a tiny seed of ice. As the crystal grows, intricate branches emerge, each following simple geometric rules. The final shape appears exquisitely ordered. Yet its formation increases entropy overall. Heat is released into the surrounding air as the crystal solidifies, dispersing energy outward. Local order rises. Global entropy still grows. This is the quiet harmony you begin to notice. Entropy does not forbid structure. It makes structure possible through gradients, through differences in temperature, pressure, concentration. When there is imbalance, motion begins. When motion begins, patterns can emerge. If everything were perfectly uniform, nothing would happen. No wind would blow. No currents would flow. No stars would ignite. Total equilibrium would be still and silent. Instead, the universe hovers between concentration and dispersion. Enough order to create form. Enough freedom to allow change. You might imagine entropy as a great leveling force, smoothing out extremes. But in the process of smoothing, it often carves pathways. Rivers erode mountains not randomly, but along channels shaped by gravity and resistance. The result is a landscape of valleys and ridges, a pattern born from gradual redistribution. The same principle shapes galaxies. Vast clouds of gas collapse under gravity, forming spirals that rotate in elegant arcs. Gravity pulls matter together locally, creating stars and planetary systems. Yet as stars shine, they radiate energy outward, increasing entropy in the surrounding space. Creation and dispersal are partners. When you zoom in far enough, every system is a dance between constraints and possibilities. Molecules collide according to precise rules of quantum mechanics. Energy levels are quantized, discrete. Yet the number of combinations grows immense as particles multiply. Entropy counts these combinations. It does not judge them. It measures possibility. You may begin to sense that what you once called chaos is simply complexity beyond immediate comprehension. A storm looks random from above, but meteorologists track pressure systems, temperature gradients, humidity levels. The storm follows laws, even if its exact path is difficult to predict. Complexity can feel like disorder because your mind seeks simple patterns. But nature is not obligated to simplify itself for you. Instead, it invites you to widen your perception. As you sit quietly, you realize that your own thoughts drift in patterns. They seem scattered at times, jumping from memory to memory. Yet beneath them are neural networks, firing according to electrical and chemical principles. Billions of neurons exchange signals in coordinated rhythms. Your mind's apparent chaos rests upon structured biology. Entropy has not erased order here. It has enabled adaptability. The universe does not move from order to pure chaos. It moves from one configuration of order to another, usually more probable one. Ice becomes water. Water becomes vapor. Vapor diffuses into air. Each state has its own structure, its own balance of constraints and freedoms. You begin to see entropy not as destruction, but as transformation. Like sand dunes reshaped by wind, patterns emerge, dissolve, and re-emerge. The wind distributes grains, but the dunes retain recognizable forms. Over time, landscapes shift, yet coherence persists. Perhaps disorder is not the opposite of order. Perhaps it is a broader canvas upon which new forms can appear. You rest with this thought. The arrow of time still points forward. Entropy still increases. But within that increase, symmetry blooms, spirals form, life adapts. The spreading of energy does not flatten everything instantly. It creates gradients, and gradients give rise to motion. And motion gives rise to warmth. You feel warmth as something intimate, a comfort against your skin, a glow in the air. Yet warmth is simply energy in motion, particles vibrating, transferring momentum through countless collisions. If entropy is about spreading energy, then heat must be one of its most eloquent expressions. You lift your hand toward a quiet source of warmth. Perhaps it is a cup of tea again, or sunlight resting on a windowsill, or the faint hum of a radiator in winter. You do not see heat itself. You feel it. A softness against your skin. A gentle expansion of comfort. And yet, beneath that simple sensation lies an invisible choreography. Heat is not a fluid that flows like water. It is not a substance stored inside objects like a hidden liquid. Heat is motion. It is the restless vibration of atoms and molecules, the trembling and spinning of particles too small for your eyes to see. When something is warm, its particles move more vigorously. They jostle and collide with greater energy. When something is cool, their motion slows. The difference between hot and cold is not a material difference, but a difference in motion. You imagine a crowded room full of people standing still. Now imagine them beginning to sway, then shuffle, then dance with increasing intensity. The room has not gained new people. It has gained motion. That motion is heat. When you touch a warm mug, faster-moving molecules in the ceramic collide with slower-moving molecules in your skin. In those tiny collisions, energy transfers. Your skin's molecules begin to vibrate more rapidly. You feel warmth because your nervous system detects that increase in microscopic motion. Heat moves through contact in this way, from faster motion to slower motion, from higher temperature to lower temperature. Always in that direction. This is another expression of entropy's preference. Energy spreads. Differences even out. When two objects at different temperatures touch, their molecules exchange energy until both settle into the same average motion. Equilibrium. You can imagine heat like a whisper passing from person to person in a long line. Each passes a little of the message forward until the entire line hums with shared information. No one commands it. It happens because sharing is statistically easier than hoarding. The science that studies these flows is called thermodynamics, the laws of heat and energy. Its principles are simple and profound. The first law tells you that energy is conserved. It does not appear from nowhere, and it does not vanish. It changes form. Chemical energy becomes heat. Heat becomes motion. Motion becomes sound. The second law, the one you have already begun to feel, tells you that entropy increases in an isolated system. Energy spreads into more possible configurations over time. Heat is entropy in motion. You picture a block of ice resting on a plate. At first, its molecules are locked into a rigid lattice, each vibrating in place but held tightly by bonds. As warmth from the surrounding air transfers into the ice, those molecules vibrate more intensely. Eventually, they break free from their fixed positions. The solid becomes liquid. The water molecules now slide past one another, less constrained, able to occupy many more arrangements. Entropy has increased. The melting ice does not represent chaos. It represents freedom at the microscopic level. And yet, something beautiful occurs in the melting. Droplets form. Reflections shimmer. Light refracts differently through liquid than through solid. New patterns arise even as rigidity dissolves. You begin to sense that heat is not merely loss. It is transformation. Think of a campfire on a cool night. Wood contains chemical energy stored from sunlight absorbed during photosynthesis. When the wood burns, that energy releases as heat and light. The flames flicker in complex shapes, fed by oxygen drawn from the air. The fire feels alive. It dances. But what you are witnessing is energy dispersing, bonds breaking, atoms rearranging, heat radiating outward. The concentrated sunlight stored in the wood spreads into the atmosphere and beyond. Entropy increases. The warmth on your face is a message from that dispersal. You realize that warmth is always a sign of difference, a gradient between hot and cold. Without difference, there is no flow. Without flow, there is no experience of heat. The Earth itself is a thermodynamic system bathed in gradients. The sun pours concentrated energy onto one side of the planet. The night side radiates energy back into space. Winds arise from uneven heating. Ocean currents circulate. Weather patterns form. All of it driven by differences in temperature. Heat moves not only through touch, but through radiation, electromagnetic waves carrying energy across empty space. Sunlight travels millions of kilometers, arriving at your skin as warmth. It is astonishing when you pause long enough to feel it. A star vibrates with nuclear fusion at its core, releasing photons that journey outward, scattering, bouncing, sometimes traveling for thousands of years before escaping into space. Eventually, one of those photons reaches Earth, absorbed by a leaf or your face. Heat connects you to the stars. In every case, energy flows from concentrated to dispersed, from hotter to cooler, from ordered to more probable arrangements. The universe does not favor tension. It relaxes it. And yet, relaxation is not immediate stillness. It is dynamic. You think of convection currents in a pot of boiling water. Warmer water at the bottom rises, cooler water sinks. Circular patterns emerge. The fluid organizes itself temporarily into rolls and cells. These are called convection cells, and they form spontaneously when heat flows through a fluid. Order arises because of heat flow. If there were no difference in temperature between the bottom and top of the pot, no pattern would form. Uniform warmth would mean no motion, no structure, no cells. Entropy creates motion by allowing gradients to exist and then smoothing them out. You sit quietly and imagine something almost impossibly small. Not a grain of sand, not a speck of dust, but a single molecule drifting, vibrating, colliding in the invisible air around you. Now imagine not one molecule, but trillions upon trillions of them, each moving according to simple physical laws, each obeying momentum, energy, direction, none of them aware, none of them guided. And yet, together, they create the warmth of the room, the softness of your breath, the gentle pressure of the atmosphere against your skin. You begin to see that entropy is not a force pushing things toward disorder. It is a reflection of counting, a quiet mathematics of possibility. Consider again the deck of cards. There is only one arrangement we call perfect order, suits aligned, numbers ascending. But there are astronomically many arrangements that appear mixed. When you shuffle, you are not driving the deck toward chaos by intention. You are simply allowing it to explore its possibilities. And there are far more mixed possibilities than ordered ones. The same is true for molecules in a box. Imagine a simple box divided into two halves. You place all the gas molecules into the left side. That is one arrangement, highly specific, highly constrained. When you remove the divider, the molecules spread throughout the box. Now they can occupy the left side, the right side, or any combination of both. There are vastly more ways for the molecules to be distributed evenly than clustered together. Entropy measures this multiplicity. It is not disorder in the emotional sense. It is the number of microscopic configurations that correspond to the same visible state. The more configurations available, the higher the entropy. You picture grains of sand scattered across a beach. If you were asked to arrange them into a perfect geometric pattern, the possibilities would be limited. But if you simply toss them loosely, the number of ways they can land becomes almost infinite. Nature prefers what is numerous. Not because it chooses, but because what is numerous is overwhelmingly likely. This is probability not as gambling or chance in a casino, but as a deep structural feature of reality. When countless particles move freely, they will almost always end up in the most statistically abundant arrangement. A hot cup of tea cools because there are more ways for energy to be shared between tea and air than for it to remain concentrated. Ice melts because there are more molecular arrangements available in liquid form than in rigid crystalline form at that temperature. Nothing commands this transition. It unfolds because the alternatives are so improbably rare. You imagine flipping a coin once. Heads or tails equal likelihood. But flip it 1,000 times, and you will almost certainly get roughly half heads and half tails. Not exactly, but close. Patterns emerge from large numbers. The universe operates with numbers beyond imagination. In a single breath of air, there are more molecules than there have been breaths taken by every human who has ever lived. When systems contain such vast numbers, probability becomes destiny. Entropy rises because high-entropy states correspond to more possible arrangements. The system naturally explores these arrangements through motion. And once it reaches a highly probable state, it is exceedingly unlikely to leave it. You begin to feel the gentleness in this idea. The universe does not rush toward disorder. It simply drifts into what is most likely. Imagine marbles scattered across a wide, shallow bowl. If you gently shake the bowl, the marbles spread out. They rarely cluster perfectly in one corner. Not because clustering is forbidden, but because spreading occupies more available space. Probability smooths extremes. And yet, probability also allows fluctuations. Every now and then, by pure chance, a small region may briefly become more ordered. A few molecules might cluster. A local pocket of lower entropy might appear. But on average, across the whole system, entropy continues its quiet ascent. You realize that even your own existence depends on probability. The atoms in your body were forged in ancient stars. Their arrangement into cells, tissues, organs was guided by physical and chemical laws. But the precise configuration that makes you this specific arrangement of molecules and memories is one among countless possibilities. It exists because the universe allows variation within its probabilistic flow. Probability does not erase meaning. It provides the landscape within which meaning arises. You think again of diffusion, the spreading of perfume in a room. At first, the scent is concentrated near its source. Slowly, molecule by molecule, it disperses. Each molecule follows a random path, bouncing unpredictably off others. This motion is called Brownian motion, the jittering dance of particles suspended in fluid. No single molecule knows the direction of the whole. Yet collectively, they fill the space evenly. Randomness at the microscopic scale produces predictability at the macroscopic scale. This is the paradox you now hold gently. Randomness gives rise to lawfulness when numbers are vast. Entropy is not chaos. It is statistics. You begin to sense how deeply this runs. The arrow of time, the flow of heat, the melting of ice all trace back to counting invisible possibilities. The universe does not choose disorder. It simply follows the arithmetic of its own complexity. And because there are so many more ways for things to be spread out than concentrated, the drift continues. But this realization opens another quiet question. If entropy increases because high entropy states are more probable, then the earliest universe, the one that began everything, must have been in a remarkably improbable state. A low entropy beginning. Why? Why did the cosmos start in such a special, ordered condition, rather than in the most probable, featureless equilibrium? As you sit with this thought, feeling the gentle weight of probability shaping everything around you, your mind begins to travel backward toward the earliest moments of existence, when order was strangely abundant and entropy had barely begun its long unfolding. Now you let your mind drift backward. Not to yesterday. Not to the beginning of your life. But far beyond memory, beyond Earth, beyond stars, to the earliest moments of the universe itself. You imagine rewinding the cosmic clock. Galaxies draw closer together. Stars collapse back into clouds of gas. Atoms dissolve into subatomic particles. Space itself shrinks, growing hotter and denser. The background glow of radiation intensifies until everything is bathed in blinding brilliance. 13.8 billion years ago, the universe was not a quiet expanse of scattered galaxies. It was compact. It was incandescent. It was almost perfectly smooth. This smoothness is the quiet surprise. When scientists observe the faint afterglow of the early universe, what we call the cosmic microwave background, they see a remarkable uniformity. The temperature varies by only tiny fractions of a degree across vast distances. Matter was distributed nearly evenly. There were no stars yet, no galaxies, no planets. At first, you might think this early state was chaotic and explosive beginning, turbulent and disordered. But in terms of entropy, it was astonishingly low. Low entropy does not mean calm or cool. The early universe was unimaginably hot. But its energy was distributed in a very particular way: smooth, uniform, simple. There were fewer ways for matter and energy to arrange themselves while remaining so evenly spread. It was an improbable beginning. You picture a perfectly smooth ball balanced delicately on the peak of a hill. It could roll in countless directions, exploring countless valleys. But at the very top, its position is specific, constrained. That is how the early universe appears, poised at a special, narrow configuration from which many possibilities could unfold. Entropy had enormous room to grow. And grow it did. As the universe expanded, tiny fluctuations in density, minute differences in matter distribution, began to amplify under gravity. Slightly denser regions attracted more matter. Over millions of years, these regions condensed into the first stars and galaxies. Structure emerged not in opposition to entropy, but because of it. This may seem paradoxical. If entropy increases, why do galaxies form? Why does matter clump together instead of spreading evenly forever? The answer lies in gravity. Gravity is a peculiar force. For most systems, spreading out increases entropy. But when gravity dominates, clumping can increase entropy even more. When matter collapses under gravity, it releases energy as heat and radiation. That energy disperses outward into space, raising the total entropy of the universe. Stars ignite because gravitational collapse heats their cores. Nuclear fusion begins. Light radiates outward for billions of years. Local order, a star forms, but vast amounts of energy spread into space. The total entropy still rises. You begin to see the early universe not as a chaotic explosion, but as a carefully balanced starting point. Its smoothness allowed gravity to create gradients, and gradients allowed motion, and motion allowed complexity. If the universe had begun in maximum entropy, perfectly uniform and gravitationally relaxed, nothing would have happened. No stars. No light. No chemistry. No life. There would be no story. Instead, it began in a state that was hot yet smooth, simple yet pregnant with possibility. Low gravitational entropy, even though matter and radiation were in thermal equilibrium. This distinction matters. Entropy in thermodynamics often refers to the spreading of heat. But gravitational entropy behaves differently. A smooth distribution of matter has low gravitational entropy because gravity wants matter to clump. As clumping occurs, gravitational entropy increases. So the early universe, smooth and nearly uniform, was highly ordered in a gravitational sense. This initial condition remains one of the deepest mysteries in physics. Why did the universe begin in such a special state? Some theories suggest cosmic inflation, a brief period of extremely rapid expansion, smoothed out irregularities, stretching space so quickly that it appeared flat and uniform. Inflation explains much about what we observe. But it does not fully answer why the conditions for inflation existed in the first place. You sit quietly with that uncertainty. The fact that entropy increases explains the arrow of time. But the existence of the arrow itself depends on the universe starting in low entropy. Without that special beginning, there would be no forward direction. Time's flow traces back to this moment. You imagine standing at the edge of that early fireball. There are no stars to look at. No darkness yet, only radiant plasma. Space and time themselves are expanding together. Every point is everywhere. There is no center. It feels both immense and intimate. Within that early simplicity lie the seeds of everything you know. The atoms in your body will one day emerge from these primordial particles. The carbon in your cells will be forged in stars born from slight density variations in this early plasma. Your existence depends on that low entropy beginning. You begin to sense the fragility of it. If the early universe had been just slightly different, slightly more chaotic, slightly less uniform, gravity might not have formed stars in the same way. Chemistry might not have unfolded as it did. Entropy needed space to grow. The universe began not at equilibrium, but far from it. You return gently to the present. The room around you feels ordinary again. But now it carries an echo of that ancient state. Every photon of light, every atom of oxygen, every heartbeat traces its lineage back to a universe that was once astonishingly ordered. Low entropy was not emptiness. It was potential. And potential is a quiet kind of tension, a stretched spring, a poised balance, a beginning that invites unfolding. The story of entropy is not merely about decay. It is about release, the gradual exploration of all the ways matter and energy can arrange themselves. You feel gratitude for that initial improbability. For the fact that the cosmos did not begin in stillness, but in a state capable of change. Because from that smooth beginning came stars. From stars came elements. From elements came planets. And from planets, eventually, came life. Local islands of order rising within a sea of increasing entropy. You might wonder, gently and without urgency, how anything beautiful survives in a universe that leans toward disorder. If entropy is always increasing, if energy always spreads, then why are there stars burning steadily for billions of years? Why are there trees stretching upward toward light? Why are you here, breathing, thinking, feeling? Tonight, you begin to see that entropy does not erase structure. It makes structure possible, but only briefly, only locally, only while energy is flowing. You imagine a river moving toward the sea. The overall direction is clear. The water flows downhill, guided by gravity. And yet within the river, there are whirlpools, eddies, spirals that form and dissolve. These patterns do not resist the flow. They arise because of it. Life is like that. Stars are like that. They are not exceptions to entropy. They are expressions of it. Consider a star forming from a vast cloud of gas drifting through space. The cloud is cold and diffuse. Gravity begins to draw particles inward. As the cloud contracts, it heats up. Energy is released. Eventually, the core becomes hot enough for nuclear fusion to ignite. Hydrogen nuclei fuse into helium, releasing immense energy as light and heat. From the outside, a star appears as a stable, glowing sphere. But inside, it is a furnace, a continuous conversion of concentrated nuclear energy into radiation spreading into space. The star exists because of imbalance. Gravity pulls inward. Radiation pushes outward. For millions or billions of years, these forces balance in delicate tension. During that time, the star radiates energy outward, increasing the entropy of the universe. Local order. Global increase. The star shines because energy is flowing from concentrated to dispersed. It maintains its structure by releasing entropy into space. You begin to sense the pattern. Life does the same. Your body is not a closed system. It is open, constantly exchanging matter and energy with its surroundings. You eat food, which contains chemical energy stored from sunlight. You breathe oxygen. Your cells break down molecules, releasing energy to build and maintain complex structures. Proteins fold into intricate shapes. DNA replicates with astonishing precision. Cells divide. Tissues repair themselves. But none of this happens without cost. In every metabolic reaction, some energy dissipates as heat. You radiate warmth into the air. You exhale carbon dioxide, a lower energy byproduct. You export entropy into your environment in order to maintain internal order. Life persists by accelerating entropy. This might sound paradoxical, but it is not. Living systems increase the total entropy of the universe faster than non-living systems would alone. By consuming concentrated energy sources and dispersing that energy as heat, life participates fully in the thermodynamic flow. You are not resisting the arrow of time. You are riding it. You are a temporary island of organization in a river of probability. Imagine a candle flame flickering in the dark. The flame has shape. It dances with recognizable form. But it is not static. It is a process, wax melting, vaporizing, reacting with oxygen, releasing light and heat. the flame exists only while fuel flows. Similarly, your body exists as a continuous process of exchange. The atoms that compose you today were not part of you years ago. They move in and out, replaced gradually through metabolism. And yet the pattern, the structure we call you, persists. Order sustained through flow. You begin to see that complexity emerges where energy gradients exist. Where there is a difference between hot and cold, between high concentration and low concentration, systems can harness the difference to create structure. On Earth, the primary gradient comes from the sun high-energy photons streamed toward the planet. The Earth radiates lower-energy infrared photons back into space. In between, life captures a fraction of that energy flow. Plants absorb sunlight, converting it into chemical energy through photosynthesis. Animals eat plants. Ecosystems form intricate webs of interaction, all powered by entropy's unfolding. The planet itself is not isolated. It is bathed in a steady stream of concentrated solar energy. As long as that flow continues, complexity can bloom. You imagine coral reefs forming elaborate architectures beneath the sea. You picture forests weaving networks of roots and leaves. You think of neural circuits in your brain firing in coordinated patterns. Each is a local decrease in entropy, a structured arrangement of matter sustained by an even greater increase elsewhere. This is the quiet miracle. Entropy does not forbid order. It allows pockets of order to emerge where gradients are available. But those pockets are temporary. Eventually, fuel runs out. Stars exhaust their nuclear supply. Living organisms age. Structures dissolve. The island erodes back into the sea. And yet, during its existence, the island shapes the flow around it. You begin to feel yourself differently. Your heartbeat is not separate from thermodynamics. Your thoughts are not detached from entropy. The electrical impulses moving through your neurons are powered by chemical gradients maintained by energy flow. You are a pattern sustained by dissipation. That phrase might sound stark at first. But tonight, it feels gentle. You are a dynamic process in a universe of processes. Your structure is real, meaningful, intricate, even if it is not permanent. Stars shine. Galaxies swirl. Life organizes itself into astonishing forms. And all of it unfolds within entropy's broader rise. This perspective softens fear. It reframes impermanence not as failure, but as participation in a larger current. The river flows toward the sea. But along its path, it carves valleys, nourishes forests, supports cities. The flow enables richness. You are one such richness. And yet, as you consider how life maintains order by exporting entropy, another layer of understanding begins to shimmer at the edge of your awareness. Because entropy is not only about heat and energy. It is also about information. About uncertainty. About the number of possible messages hidden within patterns. And as your thoughts drift gently toward this next horizon, you begin to sense that disorder may be measured not only in warmth, but in knowledge itself, in the hidden mathematics of information woven through the fabric of reality. You have been thinking of entropy as warmth spreading, as energy dispersing, as stars burning in bodies breathing. But tonight, the idea shifts gently. Entropy is not only about heat. It is also about information. You sit quietly and imagine a message written on a page. If the page contains the same letter repeated over and over, there is very little surprise in it. You can predict the next letter without effort. The pattern is simple. But if the letters vary, weaving into sentences, thoughts, unexpected turns, then each new symbol carries uncertainty. You must wait to see what comes next. In the middle of the 20th century, a mathematician named Claude Shannon asked a quiet question: how can we measure information? Not meaning, but unpredictability. He discovered something remarkable. The mathematics used to describe entropy in thermodynamics, the counting of possible arrangements, also describes the uncertainty in a message. If a signal is highly predictable, it contains little information. If it is uncertain, if many outcomes are possible, its information content increases. Entropy becomes a measure of uncertainty. You imagine flipping a coin. If the coin always lands heads, the result carries no surprise. But if it is truly balanced, each flip is uncertain. The unpredictability is what gives the outcome informational value. In this sense, entropy measures how many possible messages could exist. Just as thermodynamic entropy counts the number of microscopic arrangements that produce the same visible state, information entropy counts the number of possible signals that could occur. The connection is not poetic metaphor. It is mathematical identity. Both kinds of entropy are about possibilities. You feel something subtle unfolding. When gas molecules spread into a room, the number of ways they can arrange themselves increases. When a message becomes less predictable, the number of possible interpretations grows. In both cases, entropy rises. You begin to see that disorder is not simply messiness. It is multiplicity. A perfectly ordered crystal at absolute zero contains minimal entropy. Its structure is rigid, fully determined. There are almost no alternative configurations. But a warm gas contains immense entropy because its molecules can occupy countless positions and velocities. Similarly, a perfectly repetitive string of symbols contains little information. A rich, varied sentence contains more. Entropy bridges physics and thought. You think about memory. When you form a memory, neurons in your brain change their connections slightly. Chemical bonds shift. Electrical patterns alter. Storing information is a physical act. It requires energy. And according to thermodynamics, processing and storing information inevitably produces heat. The brain is warm not only because of blood flow, but because thinking is a thermodynamic process. Information is physical. Every bit stored in a computer, every text message transmitted through air, every memory held in your mind is grounded in physical states, tiny arrangements of charges, spins, molecules. To erase information requires energy. It increases entropy elsewhere. This insight was deepened by physicist Rolf Landauer, who showed that deleting a single bit of information has a minimum thermodynamic cost, a tiny release of heat into the environment. Forgetting warms the world, if only by an infinitesimal amount. You begin to sense how intimately connected knowledge and entropy are. The more uncertain a system is, the more information it potentially contains. When you know nothing about the position of a particle, your uncertainty, and thus entropy, is high. When you measure it, you reduce uncertainty locally, but in doing so, you increase entropy elsewhere through the energy cost of measurement. Even observation participates in thermodynamics. The universe seems to keep careful accounts. Blackbody radiation, molecular motion, digital communication all obey the same mathematical structure. Entropy measures how many possibilities are compatible with what you observe. You imagine a library containing every possible combination of letters. Most of the books would appear meaningless random strings of symbols. Only a tiny fraction would form coherent stories. The disordered configurations vastly outnumber the ordered ones. Probability shapes meaning. In physics, the most probable states dominate. In information theory, the most unpredictable signals carry more informational weight. The parallels feel almost uncanny. You begin to wonder whether the universe itself can be described as an informational system. When a star collapses into a black hole, information about the matter that fell in seems to be hidden at the event horizon. Physicists debate how that information is preserved. The very surface area of a black hole appears to measure its entropy. Area, not volume. This hints at a profound idea, that information may be encoded on boundaries, like a hologram. The deeper you look, the more the universe resembles a vast ledger of possibilities being explored. Entropy is the measure of those possibilities. You breathe slowly and feel your own mind as a pattern of electrical signals. Each thought arises from countless neuronal interactions. The uncertainty of what you will think next, even to yourself, carries informational richness. If your thoughts were entirely predictable, they would feel mechanical, lifeless. It is the slight unpredictability, the branching possibilities, that make consciousness vivid. Information entropy does not oppose thermodynamic entropy. They are reflections of the same principle seen from different angles. Possibility expanding. Uncertainty growing. Energy dispersing. You begin to feel that disorder is not emptiness. It is openness. A widening field of configurations. And yet, there are places in the universe where entropy reaches extraordinary heights, where information seems to compress into extreme forms. Objects so dense that not even light escapes. Regions where gravity and thermodynamics intertwine in ways that challenge understanding. As your thoughts grow quieter, you sense the next step in the journey toward those dark horizons where entropy becomes immense, and where the universe guards some of its deepest secrets in silence. You close your eyes and imagine drifting slowly toward a region where space itself seems to fold inward, where light struggles to escape, and where time behaves strangely. A black hole. Not a fiery monster, not a vacuum sucking endlessly, but a quiet, almost invisible warp in the fabric of space-time. You feel no gusts, no roar, only the profound weight of gravity bending the paths of everything around it. And yet, within this stillness, entropy reaches an unimaginable magnitude. You recall that entropy measures the number of microscopic configurations consistent with a macroscopic state. For everyday systems, gases, liquids, stars, those numbers are vast but comprehensible. For a black hole, they are staggering. Physicists like Jacob Bekenstein and Stephen Hawking discovered something astonishing. The entropy of a black hole is proportional not to its volume, but to the area of its event horizon, the boundary beyond which nothing returns. Every square meter of that horizon encodes information about the matter and energy swallowed inside. You begin to feel the quiet paradox. Everything that falls into the black hole seems lost, hidden beyond reach. Yet, The event horizon keeps an accounting. The universe never forgets, even in darkness. Hawking went further. Through the subtle dance of quantum mechanics, he showed that black holes are not entirely black. They emit faint radiation, Hawking radiation, losing mass and energy over time. Slowly, imperceptibly, they leak information. Entropy spreads outward even from the deepest shadows. You float closer, imagining yourself at the edge. Time slows. Light bends. Distances stretch. This is not science fiction. It is physics. Space and time themselves are malleable here, responding to gravity's immense pull. The singularity, the point of infinite density at the center, is hidden from view. You cannot reach it. You can only observe the horizon. And the horizon whispers a deep truth: entropy, information, energy, and gravity are intimately entwined. You picture a massive star collapsing at the end of its life. Its core contracts. Density rises. Nuclear reactions cease. Gravity dominates. Eventually, it forms a black hole. The local order of the star, its atoms, its structure is lost to the singularity. But the entropy carried outward by the horizon far exceeds the entropy of the original star. The universe balances its books. Nothing truly disappears. The laws remain intact. Even as your mind contemplates this, you realize that black holes are not merely exotic objects. They are extreme laboratories where the principles of the universe, thermodynamics, quantum mechanics, gravity, and information converge. Imagine the mathematics of information theory applied to a black hole. Each bit of matter falling in corresponds to a rearrangement of the event horizon's microscopic states. Every particle, every photon, every quark is accounted for in the subtle encoding at the boundary. The universe seems to be a ledger, and the black hole its most meticulous accountant. Yet there is mystery. The information paradox puzzles scientists. How can information that falls into a black hole ever return to the universe, given that the singularity seems inaccessible? The very edge of understanding flutters before you, tantalizing and unresolved. You consider the enormous entropy of a black hole compared to ordinary systems. A black hole with the mass of our Sun has more entropy than all the stars in the observable universe combined. Its capacity for disorder, for hidden arrangements, is unimaginable. And still, local order can exist around it. Planets orbit stars, life thrives, light continues to shine. Entropy grows globally, but islands of structure remain. Even near such overwhelming entropy, complexity is possible. Your thoughts wander to cosmic scales. Galaxies swirl, sometimes harboring supermassive black holes at their centers. These giants anchor the dynamics of billions of stars, yet they too release energy through accretion disks, jets, and radiation. Local energy gradients persist, complexity persists, even in the presence of extreme entropy. Gravity, thermodynamics, and information are no longer separate concepts. They intertwine. The event horizon is a boundary of energy flow, a screen encoding vast information, and a testament to the unstoppable rise of entropy. You float, noticing the subtle implications. Perhaps every particle, every photon, every interaction in the universe contributes to a vast informational tapestry. Each collision, each radiation event, each ripple in space-time is a thread in the cosmic fabric of entropy. Even you, reading these words or listening quietly, are part of the same tapestry. Your neurons fire, storing and erasing information. You feel both humility and wonder. Humility in the face of the vastness and depth of entropy. Wonder at the intricate balance between disorder and structure, chaos and comprehension. And then, you consider the ultimate fate of such black holes. Hawking radiation ensures that even these enormous reservoirs of entropy will slowly evaporate over incomprehensible timescales. The matter and energy will disperse. Information may re-emerge in ways we cannot yet predict. The universe will continue its quiet bookkeeping. The thought is calming. Entropy is relentless, but it is not cruel. It allows structure, complexity, and life to exist temporarily, beautifully, fleetingly, even as it gently guides everything toward higher probability states. You imagine drifting farther from the black hole into the surrounding space. The stars shine, light travels, galaxies swirl. You see entropy everywhere, in the radiating photons, in the orbiting matter, in the very expansion of the cosmos. Yet within that flow, pockets of order continue to bloom. Perhaps the deepest clues about reality, about time, information, energy, and matter are hidden at the boundaries, at the edges of the incomprehensible. Perhaps entropy itself is a language, a measure, a silent instruction written across the cosmos. And as you let your mind hover there, between the luminous stars and the impenetrable darkness, you feel the next question forming softly, almost imperceptibly. If black holes mark extremes of entropy, then what lies at the ultimate end of this universal journey, when energy spreads thinly across an ever-expanding space, and motion slows to a whisper? You allow your mind to drift forward now, far beyond the lifespan of any star, beyond the time scales of galaxies spinning and colliding, beyond the centuries and millennia of civilizations. You drift into the deep future of the cosmos. The universe has aged. Galaxies have grown distant, carried away by the relentless expansion of space. The once dense clusters of stars are scattered, sparse, isolated islands of light in a darkening sea. You watch as stars burn themselves out one by one. Hydrogen fuel runs low, nuclear furnaces dim, and stellar remnants, white dwarfs, neutron stars, black holes, persist quietly, their brilliance fading over trillions of years. Even light itself travels farther, losing coherence, spreading thin across the vast distances that separate these lonely celestial bodies. The warmth that once nourished planets, that powered photosynthesis and life, is no longer concentrated. Gradients of energy fade. Heat spreads evenly, approaching equilibrium. Entropy has grown nearly to its maximum. You notice the subtle rhythm in this decline. Motion slows, not violently, but gently. Particles drift with diminishing energy. Collisions are rarer. The universe exhales, stretching its vast form, settling into a quiet, almost unnoticeable state. This is not destruction in the way you might imagine. There is no sudden collapse, no violent implosion. It is a gentle fading, a balancing out, a universe reaching toward equilibrium. The stars are gone, but the laws remain. Energy, once concentrated, has dispersed. Entropy, once growing, now nears its ceiling. The cosmic stage has quieted. You imagine what remains. Black holes slowly evaporate through Hawking radiation, their massive presence shrinking to nothing over unimaginable eons. Even these reservoirs of extreme entropy yield their contents back to the universe. What once was dynamic, bright, and full of structured complexity becomes uniform, sparse, and still. The cosmic microwave background has cooled to near absolute zero, leaving only faint whispers of radiation. Motion, temperature differences, and energy gradients, the drivers of change in life, are all but gone. And yet, there is a strange serenity here. You do not feel despair. There is no loss to lament because this is not a failure of the universe. This is its natural progression. The rise of entropy has been patient, gentle, inevitable. It has unfolded over billions, trillions, and more eons, shaping complexity, nurturing life, and now guiding all toward balance. You sense the subtle poetry in this final state. Heat death is not violent. It is calm. It is quiet. It is the ultimate release from imbalance, from struggle, from concentrated energy. You picture a distant planet long gone, once teeming with life. The echoes of its warmth have long dissipated. Its energy is shared now among the void. Its entropy has contributed to the vast count of possible arrangements across the universe. All matter and energy have participated in this unfolding, each act of motion leaving its imprint, every local island of order returning to the general flow. Even your own thoughts feel connected to this rhythm. Your body, your life, your mind, temporary islands of order sustained by energy gradients, are reflections of the same principles at cosmic scale. Just as stars burned and particles diffused, so too does your presence arise and fade. The universe is not cruel. It is patient. It is constant. It permits islands of structure, complexity, and even consciousness to flourish temporarily, before gently returning everything to equilibrium. You let your imagination explore the stillness. No heat flows, no chemical reactions, no magnetic fields dance. Even atoms, for the most part, drift without interaction. The universe is vast, dark, and silent, a canvas stretched to its maximum. Entropy, once a gentle current, has reached a quiet plateau. Possibilities for rearrangement are exhausted. The universe rests, not in death, but in a state of completeness. And yet, there is beauty in this quiet. You consider the journey you have traced through this narrative, from the warm tea on your table to the swelling galaxies, from the rise of stars to the emergence of life, from the densest black holes to the faintest drift of photons across expanding space. Every step unfolded according to the same principles. Energy spreads. Entropy rises. Local order forms temporarily, then dissolves. The process is constant, rhythmic, and profoundly elegant. Even in ultimate stillness, the universe carries memory. Every path of motion, every distribution of matter, every event that once was has contributed to the total entropy. Information is embedded in the cosmic configuration, now vast and subtle, quietly holding the record of all that has unfolded. You feel yourself drifting along this continuum of time. You are aware that the principles guiding the universe guide your own existence, the spreading of energy, the temporary formation of structure, the gentle relaxation toward equilibrium. There is no rush here, only awareness. No need for fear, no need for longing. Entropy has achieved its expression, and in that expression, the universe rests in balance. You imagine the night sky of this distant epoch. There is no darkness in the sense of emptiness. Space is filled with sparse particles, faint radiation, and the whisper of a past long elapsed. The cosmos is serene, unchanging, a gentle witness to its own vast history. And yet, even in this extreme, in this near-perfect balance, you sense continuity. The principles that shaped the early universe, the flow of energy, the dispersal of heat, the growth of entropy, are the same principles that guided the formation of stars, planets, life, and thought. You feel the quiet lessons settle over you. Impermanence and transformation are universal. Order is always temporary, and yet, within that fleeting order, the universe allows wonder to exist, complexity to flourish, and consciousness to perceive. Even at the threshold of total equilibrium, there is a subtle magnificence in the universe's patient unfolding. Energy spreads, possibilities are exhausted, yet the record remains, and the quiet resonance of existence persists. You take a deep breath and imagine yourself suspended in that timeless vastness, not as separate from it, but as a small echo of its processes, a temporary pocket of order enjoying its brief participation in the cosmic story. And as you settle into this vision, your thoughts begin to drift naturally toward life, to islands of order, to the subtle ways that structure persists locally even as entropy rises globally, and to the delicate balance that allows stars, planets, and minds to emerge before fading. The universe exhales. You rest in its calm. And in that stillness, the journey continues softly, leading your mind to wonder about the entropy that dances within you, inside your own body and consciousness, as the next chapter quietly awaits. You shift your focus gently, from the vastness of galaxies and black holes to the intimacy of your own body. Take a deep breath. Feel the warmth of air moving into your lungs. Notice the subtle rise and fall of your chest. You are alive, and your life is a continuous conversation with entropy. Your cells are bustling factories, each one maintaining a delicate balance. Proteins fold, enzymes catalyze reactions, DNA replicates, membranes transport molecules. Every action requires energy, every action generates heat, every action increases the overall entropy of the universe. Yet within this ceaseless flow, order persists. You maintain structure, form, function, your cells organized, your tissues coherent, your organs operating in harmony. You are a local island of order in a sea of increasing disorder. Consider your metabolism. You consume food, concentrated packets of energy. Carbohydrates, proteins, fats, all store potential, all contain possibilities. When your body digests them, chemical bonds break. Energy is released, used to build new molecules, power nerve impulses, and maintain body temperature. The leftover energy disperses as heat. Every heartbeat, every thought, every blink is sustained by the redistribution of energy and the careful management of entropy. This is the quiet miracle. You exist because entropy is rising around you. Life is not an exception to the rules of physics, it is a consequence of them. By consuming high-energy molecules and dispersing energy as heat, you maintain your internal order while contributing to the universe's overall increase in entropy. You are simultaneously a consumer of order and a creator of disorder. Your mind is no different. Each thought, each memory, is a configuration of neurons firing in complex patterns. The act of remembering, of thinking, involves electrical impulses, chemical gradients, and molecular motion. Information processing requires energy, and energy release increases entropy elsewhere. Your consciousness is a delicate dance of order sustained through energy flow. You are not separate from the universe's thermodynamic processes. You are a temporary expression of its principles, a living computation embedded in the fabric of physics. Imagine the microscopic view. Trillions of molecules moving within you, each one following physical laws, each one uncertain in its exact path. Yet together, they form coherent patterns, a stable temperature, coordinated muscle contractions, synchronized breathing. Local order arises from global motion. You are a universe in miniature. And like the cosmos, your internal systems are subject to entropy. Cells age, proteins misfold, DNA suffers damage, neurons tire. You repair, you adapt, you replace. You export entropy to maintain order internally. Life persists, not in defiance of entropy, but through it. Even your warmth, the heat radiating from your skin, is a gentle signal of entropy at work. Every photon leaving your body carries energy outward, increasing the disorder of the surrounding environment while sustaining your internal coherence. You are both an agent and a participant in the universe's unfolding. You begin to notice the rhythm of your heart. It pulses steadily, sending blood coursing through your veins. Each contraction is a physical manifestation of energy flow, a thermodynamic process carefully tuned over millennia. Your heartbeat is a small-scale mirror of the cosmic currents you have been imagining, structured motion sustained by gradients, local order maintained by the dissipation of energy. Entropy is intimately woven into the fabric of your body. It is the hidden measure behind every breath, every flicker of your eyes, every thought that arises and fades. You are both temporary and enduring, fleeting and significant, a dynamic pattern riding the gentle current of increasing entropy. You may have felt, at times, that the universe is indifferent, that all motion and energy ultimately dissolve into heat. And yet, within this flow, local order emerges. Life thrives because the universe permits temporary structures where energy flows from concentrated sources to dispersed states. You are one such structure. Even as you ponder this, you sense the continuity of your existence with the larger cosmos. The atoms in your body were forged in stars. Their organization into molecules, cells, and tissues is part of the same story of energy redistribution that shapes galaxies and black holes. The same laws that govern the cooling of stars, the growth of entropy across cosmic time, and the evaporation of black holes are present in your veins, in your neurons, in your thoughts. You feel a sense of connection, profound and gentle. You are not separate from the universe, you are a small-scale reflection of its principles. Every action, every thought, every heartbeat participates in the same thermodynamic narrative that has been unfolding since the Big Bang. And yet, you are also aware of impermanence. Cells age and die, memories fade, patterns dissolve. Your body is a temporary island of order, maintained through energy flow and sustained against the tide of entropy for a brief span of cosmic time. This awareness is not frightening. It is comforting. You are part of a vast process, a river of energy and information that flows from the earliest moments of the universe to the far future. You are both ephemeral and eternal, ephemeral in your specific form, eternal in your participation in universal laws. You let your mind wander to the molecular level. Enzymes catalyze reactions, ions cross membranes, mitochondria generate energy. Each tiny process is a balancing act, a negotiation between order and chaos. Each molecule obeys probability, moving in ways that are unpredictable individually but predictable collectively. Local patterns arise naturally from countless random motions, and your thoughts mirror this dance. Ideas emerge, coalesce, transform, and dissipate. Memory, imagination, and consciousness are sustained by energy gradients, chemical potential, and electrical activity, a beautiful echo of the thermodynamic principles at work throughout the universe. You notice a gentle symmetry, the very forces that drive cosmic expansion, that guide the flow of stars and galaxies, are mirrored in the microscopic patterns within you. Entropy rises, energy disperses, but pockets of order persist temporarily, creating beauty, structure, and life. You feel your heartbeat again, each pulse a reminder that you are alive, a temporary order maintained within a sea of increasing entropy. You exhale, letting warmth leave your body, contributing to the universal balance, participating in the gentle unfolding that shapes all things. And as you settle into this awareness, you realize that your existence, fragile and fleeting though it may seem, is a direct expression of the same principles that govern stars, black holes, and the farthest reaches of space. You are, in essence, a local bloom of order in the grand river of probability. And now, as you rest quietly, your thoughts drift naturally toward the final reflection, the understanding of impermanence, the beauty of change, and the gentle acceptance of the universe's quiet, unending flow. You are part of a story much larger than yourself, and in that story, every breath, every pulse, every fleeting moment of consciousness carries the mark of entropy, weaving you intimately into the vast, unfolding tapestry of existence. Now, you let your mind settle softly, returning from galaxies, black holes, and the hidden currents within your body to a quiet awareness of impermanence itself. You notice the gentle rhythms of life around you. A leaf drifts on the wind. Clouds gather and scatter across the sky. Even the light that fills your room shifts subtly, filtered by dust and motion. Change is constant, gentle, inevitable. This is the world's way, nothing remains fixed. Entropy is the measure of this flow, the slow, patient unfolding that guides matter, energy, and information through every possible configuration. And yet, within this constant motion, beauty emerges. You begin to see it everywhere, in the swirling arms of a galaxy, in the unfolding petals of a flower, in the pattern of neurons firing in your mind. Impermanence is not a threat. It is an invitation. The universe's refusal to remain static allows stars to ignite, planets to form, oceans to ebb and flow, and life to blossom. Without the quiet march of entropy, nothing new could arise. Nothing could change. Nothing could surprise. You feel your body gently breathing, each inhalation and exhalation a rhythm of impermanence. Cells age and divide, molecules flow and transform, your thoughts rise and fade. The energy coursing through you spreads outward, warming your skin, fueling your mind, and sustaining the fleeting order that is you. You reflect on the stars, once formed from gravity's pull on slightly uneven clouds of gas, burning bright for millions or billions of years before fading into remnants of white dwarfs, neutron stars, or black holes. Each life cycle is a testament to impermanence, a pattern arising from energy flows, existing temporarily, then dissolving into the universe's broader stream. Life, too, is sustained by impermanence. Every heartbeat, every memory, every movement depends on energy differences and the temporary containment of entropy. You survive by exchanging order for disorder, by participating in the slow, inevitable balancing act that sustains existence. And you realize, nothing in the universe is permanent. Structures, forms, and patterns emerge only temporarily, yet their transient beauty leaves echoes in light that travels across space, in heat dispersed into the cosmos, in information stored in memory. Even impermanent events have lasting significance. You allow yourself to imagine a universe entirely at rest, maximum entropy achieved, no energy gradients remaining. At first, it seems empty. But you understand now, the value of impermanence is not in the stillness, but in the unfolding that precedes it. Every star, every planet, every life form exists as part of a continuum that temporarily resists equilibrium, expressing structure and creativity before dissolving. You notice the gentle pattern in all things. Order arises locally, persists briefly, and yields to a broader tide of entropy. This is not failure, it is transformation. Chaos and order are intertwined, like waves rising and falling, never separate, always connected. You think of yourself. Your body, your thoughts, your heartbeat, fleeting as they are, participate fully in this dance. Every experience, every sensation, every thought contributes to the broader unfolding, leaving subtle traces in the world, in the energy you radiate, and in the information your mind processes. You are a temporary bloom of order, part of a cosmos that celebrates impermanence through endless transformation. Even love, even creativity, even consciousness is sustained by this principle. Moments of connection arise, endure, and fade. Yet their influence ripples outward, shaping possibilities and leaving echoes in others' lives, in memories, in stories, in shared experience. Transience does not diminish value, it defines it. You feel a gentle acceptance of change, a calm recognition that impermanence is not something to resist, but to embrace. In every shifting leaf, in every passing cloud, in every fleeting thought, you sense the universe quietly teaching you this truth. Your mind drifts to the concept of time itself, which is deeply tied to entropy. Time flows forward because entropy increases. Past and future are defined by the movement from lower to higher entropy. Without change, without transformation, the arrow of time would not exist. And without time, there would be no becoming, no unfolding, no possibility for experience. You feel gratitude for the quiet rhythm of change. The universe does not hold still, and neither can you. Yet in participating in this ongoing transformation, you find harmony. Your impermanence is not a flaw, it is the expression of the same principles that govern stars, galaxies, life, and thought. You notice the interplay of order and disorder in your own mind. Thoughts emerge, linger, shift, and dissolve. Emotions rise and fade. Memories are recalled, reinterpreted, and reshaped. The mind, like the cosmos, is a dynamic system, local order sustained through flows of energy and information, continuously adapting, continuously changing. You begin to sense a profound connection between yourself and the universe. The principles of thermodynamics, the rise of entropy, the temporary islands of order, all are reflected within you. Your existence, ephemeral as it may be, is a microcosm of cosmic processes. You are simultaneously transient and integral, fleeting and meaningful. As you lie or sit quietly, you feel your body relaxing, each breath a soft wave of energy flowing outward, each heartbeat a gentle pulse echoing the rhythm of the universe itself. Entropy is not a distant abstraction, it is intimate, personal, a law that courses through you even now. And as your awareness drifts towards sleep, you embrace a final, gentle thought: the universe is a constant unfolding, an endless flow of transformation. Nothing is permanent. Nothing is fixed. And that is precisely what allows stars to shine, life to exist, thoughts to form, and love to bloom. Impermanence is a gift. Change is a quiet miracle. And as you close your eyes, you feel a serene harmony with the universe's patient, unending flow. Disorder is not failure, it is the means by which beauty, complexity, and life itself can arise. The cosmic dance continues, both outside and within you, as you drift slowly, gently, toward rest. And in this quiet surrender to impermanence, you sense the calm joy of being part of the universe's quiet, unfolding story. Sleep comes easily, as the awareness of entropy, impermanence, and transformation settles over you like a soft, warm blanket. You are a transient bloom of order, a participant in the cosmic tide, and in that participation, you are at peace. The universe exhales, and you drift with it.